you can just introduce which classes you are in, which year. I know a couple of you. So you are first year. I know you. Right? You?
I'm Raghav, I'm a second year and I'm a math and data science.
You?
I'm Nathan, double major computer science eco second year.
Second year. You?
I'm Malika, I'm a fourth year, I'm a history major.
History major. You are interested in data, right? Probably history you deal with all these years and dates and everything, right? So, okay, good. You?
I'm Sarah, I'm a second year, I'm a computer and data science major.
Okay. You?
I'm Khushi, I'm second year, psych and CS major. Psychology and
Psychology and computer science. Wow. You? Second year.
Yeah, I'm a second year, I'm a data science major.
Data science. You are in first year exploring. You know, I know you, I know you. Okay? So, a couple of you know me. Right? So, my name is Chiranjib. I am primarily a physicist. So, and this is the picture from my graduation days, 1994, when I was in college. Like you, very confused. I joined the movie club. Right? You joined the cyber club, you joined the movie club. And this is the image of Pluto, 1994. Right? So with the telescopes, so all the astrophysicists, they got the signals from this telescopes, and this is how Pluto used to look like, 1994. Right? And now Pluto looks like that. That's also a digital image. Right? So and people have used concepts of data science, other science and everything to come up with this. So the technology has advanced 30 years. Technology have advanced that way. Right? So when we started in my graduation days, the field like data science didn't exist. Nobody worked on artificial intelligence. So, but the same mathematical techniques what you learn in data science we used to do. This picture was developed using a concept like called Maxwellian convolution. So this is a mathematical concept, right? And here in data science, when you do random forest algorithms, right, to find some features out of it, that's some kind of convolution. Now we call this data science. The mathematical techniques behind data science was there for so long. It's long enough. So only the subject was named data science just a decade back. This is what happened. This is the reality. And other than teaching at Krea, so I have a position at Shell. I'm the head of engineering, and my team develops scientific software at Shell. And Shell, if you know, that's the logo, yellow pectin with red. We basically sell oil. That's what is known, right? So, but over there, just like we have emerged a field called data science, that has changed the landscape. In our business, we have changed the landscape. We are not an oil company anymore. We call ourselves energy company because we work on the entire energy value chain. But primarily, it's oil exploration. That's what we do. And why I am saying all these things, because in the next few slides, what I want to keep that what I do, my group does, and what their possibilities are. That when you are studying computer science, when you are studying data science, what you can do. This is not everything, but this will give you some glimpses. And at the end, I will try to relate to what the other faculties are doing in this building. So we have computer science faculties, we have data science faculties, we have chemistry, physics, mathematicians, everybody is doing something. So there are enormous possibilities that just by studying data science, studying computer science, you actually develop something what I have shown before. That's a body, astronomical body that I was interested in to study when I did my PhD in cosmology. But behind the scenes, what worked is heavy computer programming. Right? And in that process, from a physicist, I became a computer scientist and I teach computer science. Right? I never studied computer science. I've never studied data science as a course. But what I'll be sharing is what I have learned over the years during my job in interacting with bright minds like you, doing research in my core field. Computation is always a technique for me. Just like you have calculators to add numbers, subtract numbers, this is a technique that we use. Right? So why I am saying all this? See the title that I have chosen very carefully. So why I choose plus plus? If you see the history of programming languages that we use, initially 1965 Dennis Ritchie, they have invented a program called C, and the input version is called C++. What you are doing is now data science, right? But the goal is to go towards the plus plus thing so that you know what to do after this. That's why I very carefully chosen this title, and the goal of the cyber class is probably that plus plus thing, right? To do something, to get something in the plus plus thing, right? Let's see. When I say that I work for an energy company, primarily it's an oil exploration. This is an image from the oil field. So mid of the sea, there is a structure like this. You have seen National Geographic, right? National Geographic, you have seen the mid of the sea. So we basically try to explore oil, which is below the sea, below the surface, and we put the pipelines, get the crude oil, and from that crude oil, you see the ship there next to that. After exploring the oil, this is a vessel, just like your water vessel. This is a vessel which carries the hydrocarbon. It is filled, and then from the mid of the sea, it brings back to the refineries which are at the shore. Right? And in reality, what happens that when it comes, it encounters situations like this. This is reality, right? This is very hazardous. So now the question is, how the engineers will design the ship which can sustain the tsunami waves? How the engineer will design the platform which can sustain the tsunami waves? And then when this ship is carrying hydrocarbons, this is like if you rotate this bottle, make it vertical, horizontal, like the ship is moving like this, and the wave is hitting. What will happen? You shake it, right? While shaking, the water or the fluid inside it moves and it touches the boundaries. So this phenomenon is called sloshing. The name of this phenomenon is called sloshing. And since this is hydrocarbon and the walls are made of metals, there is a friction, and that friction can catch fire. So how do you prevent it? So there is an optimal height of fluid that you can fill. You can fill the full tank. You cannot, because in this sloshing, from the liquid the gas will be generated, and if there is an explosion, it will burst. So this is a hazardous industry that I work in. Right? So why we are talking about all these things when you talk about computer science and data science? Because no other engineers, nobody will try to build this and then test putting it on the sea and then see what happens. That's not possible. Not a possibility. Right? What do? We do the same experiments in computer, digital experiments, right? That's where simulation comes, that's where data science comes. And see, this is a software we have built. This is a software. Okay? So this is a software just like any other software we build. But the beauty of this software is, this is the software where I can run the simulations. So to run the simulations, first what do? We build the model. Right? We build all the CAD designs, engineering designs, build the model. Once we build the model, then we try to simulate. We basically try to see how the fluid, the water, is interacting with the solids, with the structure. So we call this fluid and structure interaction. This is we simulated. And at the end, we wanted to have some results and we want to visualize. Right? And this is what we visualize. See, this is a movie going on. There are the two ships, there is a platform, wave is coming, right? So this is the experiment that you can do. And you can stop this anytime. I can probe inside what's happening, that when it is hitting, what is the pressure, what is the force that is imparting, and that I can do because I can do data science, I can do computer science. The backbone of this is data science, computer science, and other domains. This is why we need, right? Probably it's clear now that in our industry, why we need experts like you who understand computer science, who understand data science. This is one part of it. Right? Now, so probably you have seen this. Now there is a saying called data is the new oil. Right? Why we say so? Because in our industry, in the energy industry, right? These are all the areas where we have businesses. Starting with explorations, we have wind farms, we have weather stations, we have EV charging stations. All these things we work on, and everywhere either we generate data or we start with some existing data and start to do some modeling. If we generate data, that's the numerical simulations that we do. And if we start with the data and want to get some insights from the data, that's the part of data science, right? But the problem with data science is it's very easy to lie with data. You can interpret the data the way that you want, but how exactly you can gain insight, that's the question. If you are doubtful, there is a terminology that we coined. So basically, if you manipulate with statistics, we call this statisticalization, right? It's a curve fitting. In high school, I have done it, probably you have also done it, right? So in the experiment, we forcefully fit the curve and then back calculated and saw that okay, this is the result. Data science, this is the problem. Accuracy is the problem. And if you are still doubtful, these are standard classical examples, right? So there is a problem in sampling, that when you do data science, there is an inherent problem in sampling. No, the entire space is not fully sampled. There are some void, some data which are missing, some data which are not right. And sometimes the number has some biases. So if we have those two, it's very difficult what to interpret. How to interpret, probably you can apply different mathematical techniques, but what to interpret, what to get, it's very difficult. And the end result is we have seen that the exit poll predictions versus the actual results, they varies very differently. And for the first thing, that when I am saying problem in sampling, that if I give you a cell phone usage data from 2005 and want you to predict what is the usage pattern going to be next month, you will not be able to do that, because the code data has changed. That's why it's very easy to do it live with statistics, right? It's very easy. Same technique, if you have the wrong data, you get the wrong output. So that's why I think many a times we get overwhelmed with that, okay, data science, AI can solve everything. So that's, to me, I think probably that's a sci-fi dream at this moment, but we are not ready for that yet. Why? Because this is actually the snapshot of the oil plant, the refineries, right? This is the image from a plant called PARL. It's a GTL stands for gas to liquid, because petrol, diesel, what we use, 70% are not dinosaur oil. There is a misconception that everything is explored from the ground. That's not true. 70% is something where you converted natural gas to hydrocarbons. So you have methane, right? So you converted that to hydrocarbons. And these are the plants where you convert those hydrocarbons, gas to liquid, right? And there are so many pipes, so many sensors, so many everything, right? And if I want to know when my equipment is up for maintenance, how do I know? Right? Just like you know that when you have to charge your cell phone, because there is an indicator saying that you have 3% less, 3% remaining, 5% remaining. There is an indication. But if you have an equipment, you know when this projector will be due for servicing? Nobody knows, right? If you don't know about this projector, that while we are talking, this bulb can go wrong, right? What will happen? We will move to the next room, right? But in our business, in any of these kind of heavy industries, if a sensor like this goes off, if the equipment goes down, what will happen? number one, there is an economical impact. There is also a hazardous impact. Somebody can lose their life. Right? This is so critical. And that's what, when you bring artificial intelligence and data, we have to be extra careful in our industry. Right? And why this is, we have to be extra careful? Because now we are talking about a scale problem. So if this projector goes down versus one of the unit of this plant goes down, this is a scale problem. Right? Everything is at scale. Right? Our thought process has a limit in scaling. Similarly, all these models that we do, data science model, even the data analyst what they do, what is the data scientist that they do, every model has some limitations. Just like our thought process. Let me ask you a question. Let's say I give you 1,000 rupees and ask you that in Krea you need to spend 1,000 rupees in a day without buying anything. We can only spend 1,000 rupees on some experience. Anything. We cannot buy something materialistic which you can hold back. How do you spend 1,000 rupees in one day? Probably you can go have some good food in the canteen, other pizzas, go with friends, you can do that, right? That max.
Pulikat Lake, boating.
Voting. Okay, good. If I give you 10,000 rupees, want you to spend in a day, what do you do?
Go to Chennai, some mall.
You cannot buy anything.
Yeah,
See,
but
you cannot vote, yeah.
like you could just go to the arcade.
Arcade, okay. Then you spend on experience.
Yeah.
See, if you get 10 instead of 10,000, if you get 1 lakh rupees, want to spend in a day without buying anything which you can hold back. Can you do that?
Rent a luxury sports car.
Yeah. In Krea, I am telling that you are in Krea.
Sri City Airfield helicopter.
Okay.
I think you close the budget.
Okay, helicopter, that's fine. So you can get a helicopter ride, buy an experience. Let's say you increase the limit 1 lakh to 10 lakhs.
You got helicopter.
Huh?
You got to go to Chennai, fly to I don't know.
In a day from Krea, that's the condition, right? At the end of the day, you need to come back to Krea.
Buy your own car.
Yeah, I just want to know, right? 10 lakhs. Right? Can't spend. Can? Huh? We can? I'm here.
You can go to Andaman or something and come back in a.
In a day, I'm saying that you are in a Krea. I give you in the morning 1 lakh rupees.
If you had like 50 lakhs, then you can, because then you can do private planes.
Yes. Just like that. So, what I wanted to say is, our thought process has a scaling limit. We cannot think beyond something, right? Similarly, all this data model has a limit. We cannot go beyond that. That's the challenge, right? Now, when you build artificial intelligence, I will show you some example. So, this is the definition of artificial intelligence. If you go to Merriam-Webster and search what is artificial intelligence, all the time it says that it's trying to imitate intelligent human behavior. Right? So just like your thought. If you ask ChatGPT, hey ChatGPT, I have 1 lakh rupees, I am in Krea, tell me something so that I can spend 1 lakh a day. Right? So machine is thinking on your behalf. Machine is thinking means some data is thinking on your behalf,
You
right?
go to charity. That's an experience.
Wow.
So then there's no limit.
Super wow.
Huh?
Review vendor for food.
Yeah.
What?
He said that way of like bring a new vendor or something.
Okay, so you can at the end of this thing, probably you can start a project there to test the scale of thought process of human being, right? That's a good exercise.
So we can invest in stock.
I said you cannot hold it back. You
Yeah.
cannot hold it back. So this is a weekend exercise, okay? Write to me on Monday that what you thought about, right? So I want to see that up to some point, after that you cannot imagine, right?
When I think something like charity, there's no limit. You can give as much as you want.
But that's not then this is then because you are trying to fool the system. That's the statisticalism, right? That's the statisticalism, right?
Why is it statistically?
Of course, statisticalism. Because I told initially that you can spend on your experience.
So, charity, giving money to charity is an experience.
So then our income tax department will come to you if you do it multiple times. They will say that they will think that you are siphoning money, right? So maybe you have a good heart, you have a good intent, but at the end it's going to happen, right? Unless you are politically connected or you have some certain surnames, right? So income tax department will come after you. It's the
It will
reality.
take them more than a day to come on. I just wanted to explain.
Okay, so think about it. We have the weekend, entire weekend to think, write me back on Monday. Okay, coming back. What do you mean? Why I am bringing the concept of scale that when I am talking about artificial intelligence, right? Think about, you did this when you were all kids. I did it with my daughter. I taught her how to cross the road, right? So look at the signal, look at the right side, look at the left side, you cross. That's the kind of programming you are doing it in Python, in your laptop, right? Very simple. But when you are dealing with large data, this is scale. How do you cross the road? How do you cross the road?
If the vehicle is just like moving very slowly, you can just go like that.
You can go, right? Now if you have this kind of data, how do you go?
Build a subway.
Yeah, window, bridge.
But right now this is the problem with the data, right? Sometimes it's so unstructured that you need to bring some insights from the data is very difficult. So what do we do? Even in our life, what's the easiest solution? How do you cross the road? Let's see. What's your how your thought is scaling? I have to see ideas. How do you cross the road in this kind of situation?
Join with the crowd.
Yes?
Using the speaker.
Then who will be on the front? You can join in the crowd, but who will be at the front? Will you be?
That's all for me.
I mean, I'm pretty sure that people who frequent that area, so they'll know, but they'll have more experience, so they'll probably be at the front.
So you follow somebody else. That's what you mean, right?
Yeah, someone who has more experience navigating this region.
Good. Something.
I use speaker.
Do you think this kind of guy will listen to your speaker that you will say that I want to cross the road and it will
People
stop?
can join me if I'm using the speaker.
Where are you from?
I'm from
Pune. You have ever been to Bangalore?
no.
Come and try. Okay. This is what happens. So what we bring is, if this is the data, we basically bring some constant in the data to extract some feature. In this context, the constant is the traffic cop. That's the easiest solution, right? This is what you do. This is reality, right? You have seen this. But when you are building your AI models, have you thought about constant is something like this? Probably not. Right? So at the end of the day, when you are dealing with data, you are dealing with artificial intelligence. The goal is to bring some order out of chaos. And this is a book by an author called Ilya Prigozhin. He is the Nobel laureate in chemistry in 1977. So the library has a copy of that book. I want you guys to go and search this book. Right? Must read. If you are trying to explore something in data science, you should understand what does it mean, how to extract information from a chaotic situation to make it ordered. Right? How many of you have taken thermodynamics class? Thermodynamics class in the physics chemistry major?
Oh, in 10th class.
10 class? You heard about the term entropy, right?
Yeah.
Yes?
Entropy.
Entropy you heard?
Yes.
Go and search. So basically in the data science space, we are dealing with an entropy problem. Right? We wanted to bring order out of all this scattered information. Right? And why you want to do that? Because there are three things that we do. The data can be either descriptive, the data can be predictive, or data can be prescriptive. Descriptive means I give you a text file, so you do some natural language processing and say bring out some description out of it, some insights out of it, right? That's the descriptive part of the data science. And then you do something predictive. Predictive means based on some historical data you are predicting something, okay, it might happen. I can say that based on if I have the usage data of this projector, I know that the bulb is supposed to be changed in every 6 months. So I will say that the prediction is if you have changed it in now, 6 months down the line, it's due for change. This is predictive. And what is prescriptive? Prescriptive is basically giving you directions. The way that the traffic curve has given, this is the prescriptive solution, right? So this is data science. And if you do that, that's no longer an artificial intelligence, it's actually become advanced intelligence. And that's what you should be targeting for. All of you, right? When you are doing data science, you are building AI models, it's not artificial intelligence. Because if it is artificial intelligence, then still there is some doubt that you will have. So all of you fly, right? Right? All of you fly. Either going home or something. Many times you heard that it's running on autopilot. Right? That automatically determines. But will you be able to fly if you know that the pilot is working from home and from starting it will run on autopilot? Probably not. Right? So that's the confidence level, because if it is running on autopilot means there is some prescriptive or predictive thing that's happening, that the traffic control, air traffic control is sending to the aircraft with some communication and they are saying you take this route, take that route, right? But you will not do that. So that's what, if it is artificial, then theoretically you can say that yes, everything is okay. But we have to rely on something called advanced intelligence. And if you do, that opens up possibilities in many different areas. And these are a couple of examples. First is going to work on some data science project with the Department of Health, right? So actually there is a project called Cardroid. It's a cardiac problem. So they wanted to do some predictive cardiovascular health. So based on the data from the patient, so a bunch of data scientists, bunch of AI scientists, they created a model to predict the health of the heart. Right? That's one area. So the first picture that I have shown you from Pluto, this is very similar. We wanted to see what is the solar weather modeling, right? We basically have all this digital data, and these days, if we take a picture, means we are basically storing data, JPEG or RAW, whatever format. It's eventually it's data. We are processing the data. Even when you are capturing these pictures or videos, we are storing this in a file format. This file format means it's data. So now there are tools you have probably seen you are using, that I upload these videos somewhere and try to annotate, try to extract information from the video, it will do that. Right? Same thing, same techniques that you do. So why I mentioned that in this building you have departments. So this is viral genome. You talk to biology department, Professor Krea, Sam, right? So he does this data science part, right? I was talking to Professor Kalyan, you have to develop something. How do you visualize this kind of thing, that we have a new molecule that is attaching to a protein? What happens? What do you visualize? And there are techniques like data science, technique like all these sciences that come into picture. How much time do you have?
Yeah, as much as you want. Like,
Much?
yeah.
So none of you have gone to physics classes, right? One, two,
I'm
classes.
doing physics.
Huh?
I'm doing physics, Professor.
You are doing.
Professor, so when you want to build software to predict something like that, how do you, where do you even start? How do you know the tools that are required to build something?
We come back. That's what. After this, after I show you, I really wanted to have this kind of questions triggered in your mind so that you become curious, right? We'll talk. Okay. So let's now understand. So everything what you have done, you are in the 5G generation, right? So you are living in 5G. You want everything now, just like that. So let's understand. Fundamentally, you know, this is standard definition, right? How many of you know what is 1 second? How much time is 1 second?
1000 milliseconds.
Yes, then it is reverting back, right? What is millisecond? How much millisecond? Yes, 1000 millisecond is 1 second, right? So you are playing with unit system. I am talking about how much time exactly is 1 second. Because for you, speed is essential for you, right?
I think it is it is somewhat related to the speed of light. I'm not sure. The amount of distance the speed of light takes to cover.
Distance is measured based on speed of light. So meter is defined based on how much time it
Okay, I am
takes.
asking how much is 1 second, right? Think. How much is 1 second? That's a fundamental question, right? So you know how much is 1 gram, how much is 1 meter, because there is a standard that is kept somewhere. There is a coin that is kept in the observatory. There is a scale that is kept in the observatory. They are saying that if this scale is 1 meter, right? That's fine. But you cannot keep time like that. How much is 1 second? How much time is 1 second?
You probably use planetary motion or something like that, the motion of planets or stars too.
Okay. What else? How can you define what is 1 second?
We take 20 years, 24 hours, and work out.
Yeah, that's what we talked about, right? So it's basically same reward, but how do you know 1 day is 24 hours? Right? 24 hours basically fundamental unit is second, right? How do you define second? So that comes from a physical phenomenon, some physics. So that's not the planetary system, but it comes from atoms. And where it comes, if you go and search Wikipedia, you'll see this is the definition that is given. What does it mean? So many numbers. And exactly, if you just go, see, this is I have highlighted. This is the definition of a second. And why I am showing all these things? After a couple of slides, you will realize that why I am doing computer science now. Let me explain you this little bit of physics. So this is how the atom is structured, right? You have a nucleus and the electrons are moving, and we call these are called energy levels. Our physics and chemistry departments, if you go to Professor Shiva, he will explain it. You go to Kalyan, they will explain it. This is how the structure of the atoms is, right? And these energy levels can be splitted. If you put anything externally, some extra force, then you can split the atom. We call this fine structure. And if you further push something, we call this again splitted, we call this hyperfine structure. This is the hyperfine structure. If you see that at the corner I have written hyperfine structure. Actually second is defined like this. If you take a cesium atom, you know that like hydrogen, oxygen, sodium and all, cesium is an element. If you take a cesium atom, in cesium atom we call this ground state. The particular time that the electron takes to come from that state to this state, the amount of time that it takes, that's the definition of the second. And this is so precise that all our GPS clocks, all the rocket launches, when the rocket is launched, right? Everything is very precisely calculated. So we need to precisely define what's the definition of the second is. So this is an experimentalist have verified. But as a theoretician, if somebody asks you, can you calculate how much time it will take for the cesium, the electron in the cesium atom to jump from that level to that level? You need to calculate, you need to simulate, right? That's what your fundamental things start at, where to start. You basically start solving equations. This is the periodic table. If you have seen, if you remember from your college days, this is the periodic table. And those elements is lithium, sodium, potassium, rubidium, cesium. These are called alkali metals. So cesium has 55 electrons. That's the structure, right? That's complexities. And at some point I started calculating those properties of this cesium atom, how much time it will take. This is one of my old publication, and that's where I started moving more towards computer science. Because to solve this, I need to solve a set of equations. And that's what you asked, right? Where to start. So this is how the equations look like, all Greek, right? And if I expand, there are many different techniques to solve these equations. Just like you have algebra courses, right? You can solve the partial differential equations in different ways. You can do a numerical integration in many different techniques, right? You have Runge-Kutta, you have many other things. Even in data science, same optimization problem you can solve using gradient descent, you can solve using non-gradient methods and others, right? Yes.
I'm sorry if this is deviating a bit, but why is it exact same one every time?
Why?
Is the 1 second exact same? I mean, the time taken for the electron to go from one.
That's how nature behaves. That's how nature behaves. That's how the structure is, right? And that's you have identified and you have done this experiment again and again and again. And that's what people realize that okay, this is the thing that we can take this as a standard. And when you solve this, there are many techniques. So you expand this, write long equations, and if I expand this, one of the equations here looks like this. This is the expressions, right? And this is only the expression from this term within this 1 plus t1 plus t2 square, all these things. This is the expression looks like. Some part of it. There are many other things I didn't take it, right? If I want to solve this using any kind of program, what I typically need is I just highlighted something on the red, right? I see, you will see what kind of things are happening. So we have an iterative summation here because I have the sum here, right? And then I am doing a scalar multiplication 2 times, that is a scalar multiplication, and then I am multiplying with some tensors which has different 4 components. So this is the kind of mathematical operation that I am doing. If you are doing any simulations, any data science modeling, fundamental mathematics is very similar. That's what I am showing you, right? And when you do that, how do you code that in a computer? Can your Python code do that?
With NumPy maybe,
How much time it will take?
probably a lot.
Yes, how much long time?
Depends on how
Depends
you use
on
it.
how large the numbers are.
Yes.
You can also perform parallel computing or something like
There
that.
will be a big notation for it.
So if you don't do Python, why not only Python? Why not something else?
C will be faster or C++ will be faster.
Yes. So definitely C++ will be faster, and why faster we are discussing in our 312 classes, right? So from a computer science perspective, if you are solving this as a data science problem, why you need to know computer science? Because this you need to map that with 4 things. How much memory that you need in your machine, what kind of computing that you are doing, what kind of storage that you need. You don't know how much data that it will produce. You have no idea before you do. But you can, if you have a better idea, you can basically solve this problem more efficiently. And that's what I started moving from physics and moving towards computer science. And again now what my observation is, this is actually a last mile connectivity problem. You know how to solve equations, you know what the problem is, but you don't know how to connect the last mile. For example, what I mean by last mile connectivity, how do you come from your home, Pune to here? From Pune, how do you come?
Yeah, from home to airport, take the ocean.
Auto.
Yeah, then
So, is the time fixed?
time is not fixed.
Not
Depends
fixed.
on traffic.
Your flight time is fixed.
Yeah, it is.
But after the flight collecting the luggage, that time is not fixed. Right?
Sometimes delay.
Sometimes delay. And then from there to reach Krea, that time is also not fixed. Right? So although some part that you can do it very efficiently, you have a very high-end computers, you can process this. Right? But at the beginning, at the end, if you cannot be efficient, your entire thing is very slow. Right? That is called last mile connectivity problem. What we just discussed is the last mile connectivity problem, right? So in data science and AI, this is the problem that we face. How do we know that I get the data in a real time? For example, you are using Google Maps, right? You want to search, you are searching directions. You go from this point to that point. Think about a scenario that you are driving, your co-driver is searching which way to take, and the Google Map is not responding. Moving. What will happen? You will miss the exit, right? You go further, you need to come back, you will miss it, right? So performance is very critical. And how do you ensure that the performance is critical? You need to do a better program, right? So you need to really understand how computer behaves, right? Data science is not about writing a Python code. Data science is not about knowing TensorFlow. Data science is not about knowing NumPy. It's about making sure that you have a solution which can meaningfully give you some insights in a reasonable amount of time. That's why understanding time is also very important, right? I will show you some real examples if we have time. But I mean that eventually it's a combination of everything. When you are doing data science, when you are doing computer science, where are you going to use it? You are going to be using solving some problems, right? That problem is some real life problem, maybe a physics problem, maybe a chemistry problem, right? So what I encourage that this club, you not only focus on only the data science or the computer science part, but also try to people like you should come and talk about your domain, right? Yes. What's happening? I am talking about history. Yes. So we think that because history is such a subject and it has a huge text, so can you speed up extracting information from the huge text? This is you face the problem, right? That's a classic data science application problem. So whatever you are doing, it should be driven by the domain, driven by the applications, and you actually need to bring everything, right? See, a few more things to show. Now it's time to talk about this university, right? This is, I just took a picture there, right? So your ethics is very important. Like your behavior, when you are doing data science, data ethics is very important. And that's why you avoid manipulation, right? What you are doing, excellence is very important. Inclusivity is very important. This is one of the charters that this club should have, right? Cyber Club is not only for data science and computer science, it has to be inclusive. And most importantly, at the end, it has to be your accountability, right? Just to excel, right? We can tell, okay, you can do this, you can do that, but you have to own that accountability. You have to own, you have the sense of ownership, right? This is very important. Now, the last part, but very interesting part. Again, your weekend exercise, weekend thought process. I think we have chicken today, good food, right? You have seen this picture. Do you recall? This is the image from a movie, Titanic, right? All of you have seen this. How many have you seen this picture? Not seen, right? This is what you do. At the end, what people see is the left side. But this is how it is made. This is the behind the scenes, right? This is where your roles looks like. And at this moment, if you don't play your role, you have a very difficult future. Why I am saying? Because we are going through an energy crisis, right? Everybody needs energy. Your cell phone needs to be charged every day. If you don't run any apps, if you disable your data, your cell phone will survive for a couple of days, just for while. As soon as you open up your data, start running apps, your phone will start running out. So energy consumption is very critical. So now think about, we are running this massive data, generative AI, chat GPT, everything is getting trained. Do you know how much energy that is spent for that? Any idea? Compared to, let's say, getting 1 lakh flying to Andaman. If that is your benchmark, how much energy that is spent to train a chat GPT model? Let's see. How many of you can think? That's the data. If your round trip flight from New York to San Francisco per passenger is 1984, so 230 million parameters transformer chat GPT model takes this much of energy. It's mind boggling. And every now and then you are using chat GPT to answer your question papers, right? This is mind boggling. That's the challenge. When you are dealing with data, unless you understand that this is the problem that you are going through, will not know. If you are from Bangalore, you know that recently you have gone through a water crisis. There is no water absolutely, right? We have gone through a water crisis because of us. So we have not worked on water conservation. Same thing we are going to face, a crisis. I think it's okay.
It turns off at 10.
Predictive maintenance. This is the crisis that you are going through. So for you guys, other than doing a data model, other than solving simulation models, this is the challenge. This is the data center typically looks like. So the next goal for the community, not for you guys, but overall the computing in the world, what we are going through, is how do we make computing green? That's the next generation challenge. Because now we can solve problems. We can build AI models, but simultaneously behind the scenes what happens is we are adding to carbon footprint. We are adding to carbon footprint. This is the challenge that we need to address. You can do AI model maybe to see, do a modeling and then do some prediction. Okay. For example, in this entire building, how many lights are there? If you can build an AI model and say that this place is having this much of energy that you are spending, can you switch it on? Right? Is there an automated way that you can figure out that if nobody is there, you switch off? Right? So minimum contribution. That's the AI model can do, right? Otherwise, in our time, the hostel, so the security person used to come and then switch off the light early in the morning. Daylight is there, but right now you have sensors. One part of it, but sensors also need some energy, right? Can we control it centralized way? That's the AI model can do. These are the kind of things that I think you guys should focus on. And hopefully I am able to give you a picture of different ranges. This is what's there in the world. Right? I really like the campus. This is green. Right? This is the road. Just in the picture this afternoon. Right? We have to make computing green like this. And it also talks about scale, right? Your environment talks about scale. So it's not basically a bush, right? It's a huge tree. You cannot count the leaf of all these trees. It's not possible, right? That's how it has scale. So what you are doing, your data model, your compute model, it should scale like that, right? So writing a program on your Python, that's fine, but the problem relies on can you scale it? If you cannot scale it, you actually are not developing intelligence, right? Because learning ABCD, nobody will say that okay, you are intelligent. But intelligence means you are able to take decisions. When you can take decisions, that means you have achieved intelligence. That's how we do, right? Natural intelligence. The same thing for machine. And we call this artificial intelligence. And the goal is to go from artificial to advanced. Okay? That's it. Let's go for it. You can ask me anything except my bank balance. Okay? Feel free.
What's this QR for?
So that's my presence on the web. And you can search me here. You drop me a note. You can. So that's my LinkedIn. Right? So we have talked with other faculties in different departments that how we can make sure that you guys flourishes in this club, how you can do, what kind of projects that you can do so that you can learn and you can do stuff. So things have just started, but again the conversation started with we can give you one-sided story, but you have to come participate actively and also think about contributing back. So next time, so basically you are the ambassador of the club, right? That's probably, it's a very good start. So in my times we enjoyed the movie club. I wish we have this kind of clubs. We had journal clubs, definitely we had journal clubs, but not a data science club or an AI club. But I really have very good memories of my movie club those days. And when you grow up, This is something you should cherish. Make sure that you work towards that and then you cherish that, yes, we are doing something. Yeah, so this is what I wanted to share with you. The goal is, ask me anything if I'm traveling back tomorrow. So when I teach, I typically teach online and I try to spend a week during the trimester. So next trimester, this trimester we are going through principles of computer systems, where you talk about the first page, that how much memory that we need, how much disk space that you need. We discuss all these things. We understand that how computer behaves. And next trimester there will be an elective on high performance computing, because everything needs to be really high performance. So hopefully I will be teaching that. I offered the course. So if any of you guys are coming, but the requirement is that Python is not good enough. You should learn C or C++. So that is important. And why I am saying so? I will show you two programs. I am just adding 1 billion numbers written in Python. Just adding. Right? I have the same thing. I am doing it in C++. Trust me. Just before that I was the first one it takes, that when I am running a C++ program, just scanning 1 billion numbers, and this is the one that I am spending when I am doing it in the Python way. See the difference, right? When you are going for performance, Python is not good enough. So you need to be able to write this kind of code, understand this kind of code, then we can talk about performance. So this is what you do, and you think that you are doing data science. Yes, you are doing data science, but it will not scale. If for 1 billion number I am spending that much of time thinking about, I need to spend on 10 billion numbers. It's not linear. It will be forever. But if I do the same thing in the C++ way, it's very quick. But the downside is Python has pandas, Python has numpy, Python has TensorFlow, C++ has nothing. That's the challenge, right? But what pandas, numpy and everything is doing, it's basically all the existing thing they are packaged and made available to you as a function. In C++ things are not there, because when Python started developing, so the intention was to give the user a very easy to use interface so that they can code. But if you really want to do performance, you have to go C++ or C.
Professor, how about Julia? Because
Again, we'll be discussing in detail in our class. Julia is very similar to Python. Very similar to Python. Little bit of improved performance, but in C++, you see the way that we actually run an executable, right? In Julia, we don't develop executable. It's all during runtime. It translates and creates this executable internally. It will never be able to cross the performance that C or C++ will bring, right? But again, easy interface, easy to code, to proof of concept. That's fine. So then you might ask the question, then what's happening? That if I develop a model using Python, I have to throw and write everything in C++? No. So there are techniques that you actually can write a wrapper which will take your Python code, and then behind the scenes, just like this Titanic picture that you have seen, you can actually create something which will make it faster. Right? These are possible. So I'm not discarding Python, but the focus is that at this stage of your career, when you are learning, I will strongly suggest, even if you are doing data science, learn languages like C or C++ at least. Right? It's very important, because there you will learn the computational techniques. So your Python program will be much more efficient afterwards. Right? And if you are exploring a field, going for a job or higher studies and all, that's going to pay you off. That's my experience here.
Can we start with his question that he had
Sure.
asked?
Yes, you asked that where to start, right?
So how do you learn the tools required to build a software, like predicting the
Waves.
impact? Yeah.
Right? We start backwards. Backwards in the sense, when you develop a software, we first try to understand what the end user needs. Right? We start from there. If you know what your goal is and you are here, you actually can plan to go and to reach the goal. But if it's always forward, right? You are here, you start walking without knowing that what to reach, then probably you'll reach somewhere else. So thumb rule of building software is define what the end user needs. We call this requirement gathering. Right? So in our class we will have a software development lifecycle workshop, SDLC. There we will be talking about how do we capture the requirement. So I think we should open this to all. All of you should attend. So this one workshop, and the other workshop that we will have is on system thinking. How do you think from a problem perspective and then think about a solution. So that's again a workshop, it will be open to all. For this class it will be mandatory, but anybody can attend. So system thinking workshop will be in person. So some experts will be coming, my friend is coming. They will conduct the workshop, system thinking workshop 2 days, 2 hours. So first day mostly about talking about what system thinking is, how to do. Second day will be little hands-on. And the SDLC, the software development lifecycle workshops will be online. Right? So it's mandatory for Comp 312 class, but we will open this up. Anybody can join. I think Arab, you should publish that in the Cyber Club also, these 2 workshops, right? And one of you has to coordinate so that you have to tell the.
If you can give us suggestions on date and all of that, then we'll make posters and publish it on Cyber.
And for our class anyway, we'll be discussing in our class. But when you announce that when the dates, right? So we'll let you know and then make sure that you extend that to the Cyber Club. And even the entire team. So I talked with Ananna. Ananna, I think.
4th year.
Ananna Dasgupta, right? So who does this creative writing workshop?
Yeah, she's a professor.
So Professor Dasgupta. I talked with her, we discussed. So we probably open up the system thinking workshop for the entire institute. But for our class it's mandatory, but anybody can join. So that will be offline. But SDLC, I think not everybody will be interested, but at least you guys, data science, computer science, you should attend. Right? Okay. And in the Cyber Club, so Arabs, Spurs, they are already doing some projects that to help out the academic office, creating a solution, how the academic office does the scheduling of your classes, because there are many constants, you have conflicts. They are creating a solution. Eventually, that will be a solution given to the university in the form of a software.
We're opening a new project on Monday, open to everyone to apply for the media, to help the media lab.
Yes, these are the kind of things, and soon we'll be opening up some project that we have a high-end computing system we call clusters, HPC clusters. You have heard, right? So we are planning to train people who are very aligned towards Linux and systems and programming, so that they can build some monitoring tools for the cluster. So there will be projects like this will be keep coming. So these are not capstone or these are not anything. So this is a fun project. This is how the club operates. And if needed, if you want to be a summer intern for that project, we will figure it out. But all the projects, what we decided, we have been still deciding in the faculty is that each project should be assigned to one faculty. One faculty has to be a mentor or by basically owning the project, so that when you graduate and then next set of people come, we have a continuity, right? So this will happen over the time, but I think it's a fantastic start. And please participate, encourage others to participate, because a club only will sustain with your participation, right? It has to be organic, right? guys are doing very good job. So big applause to you guys and whoever has volunteered. It takes time, right? So hopefully next year when you will be moving to your senior classes, you have to step in. You have to volunteer. You have to say that okay, I want to share the responsibilities. That's how we grow, right? Okay. Hope you have enough thing for weekends, right? So I will be waiting for the answer that if I give you 10 lakh rupees in Krea, you need to spend in a day, right? So that's a data collection exercise, right? Then you will do an AI model and then see. That's a fun project. You'll see the variance of the thought process, right? Okay. Anything? If you are not able to ask now, send me an email. Set up a time. I'll be more than happy to talk to you. I live in Bangalore. Most of the time, except Wednesday evening, any other evening will be fine.
Professor, we had a few questions prepared.
Yes.
Can we just ask one or two?
Oh, of course. What time it is?
It's
10:15.
All of you have taken dinner?
Yeah, but I have a meeting.
Go ahead.
Thank you.
Yeah.
So Professor, Krea is widely recognized for its liberal arts focus, and the computer science department is also developing, and the data science department has just been formed. Like it's a new discipline in Krea. With placements in these kind of fields is still uncertain for all of us. What do you suggest that we all should do to improve the opportunities available after graduation?
Okay, so here I think this is a problem, genuine problem, right? And the solution to the problem, mostly the accountability relies with the faculties and people like us. That's why I came. Right? The intention is to basically help you guys to give you those access, right? Just by I think a placement office has a role to play, but placement is not everything. Are you ready to start a job? That if you get something in the placement, that is the main question, right? Getting a job is something, but being productive, being sustaining that job, and then coming up with something, that's another set of challenge. So what personally I think that if the job needs here after your graduation, not Krea, anywhere in India, even the IITs, right? Those students are somewhere there is a gap. And in industry, what we do is first 6 months probably put you into rigorous training, right? But how about getting that training before you join the industry? And that's what I'm coming. There is Professor Sudeep Rai in chemistry, he is coming. Another professor in biology, that they are coming. We are all coming from industry after working in 20 plus years in industry. We think that this is what you can do, number one. Number two is just like I'm visiting Krea, I represent different kinds of academic boards in other universities. So we are trying to create an exchange program with a couple of top Indian universities. One of them is IIT Hyderabad, right? So if it works out, so our students will have opportunities to spend the summer there, right? These are the kind of things will give you that exposure, give you the training, and what you need is that exposure. Right?
Correct, but like, what do you suggest that we on our own end should do to get like placements?
Okay, one thing you do is you start a project, create a bot which will scan the websites, list down all the upcoming conferences in this area in India. Right? Almost all the conferences have a section for the students to come and participate, even if you don't have a paper. Write a bot, web scroller, right? Extract all the conferences that is there. Let's see. There are many fields. You can create so many details, right? This conference starts that day. This is the registration date. This is the registration fee. This has scholarship. This is a free registration, right? Many things. Probably this is a fantastic project, right?
So you suggest that by doing projects we might gain experience.
Yeah, if you do this project, number one, you have the information. You have created a web
Killing two
product.
birds with one stone.
Correct.
You created a web product. You know the web technologies, right? But in Krea, we don't have a course on teaching you web technologies.
Correct.
So Aditya and us, we are trying to do the front end of this, right? He learned it.
Correct.
So I think you should join these guys that they are creating this table, right? Talk to him. So these are the kind of things, right? This is self-learning. And learning only happens if you solve a problem. So if you do this, but my suggestion of Arab data that you are actually getting two purposes solved. One is you getting the information, you are creating some utility which can do this crawling. Right? So it will open up enormous possibilities, right?
Correct.
If you can crawl the web and then extract information, right? So many technologies works that way. Uber works this way, right? Not on the web crawling, but Uber basically gets this, they are basically a transport aggregator, right? So if you have a web crawler, that can be used as an aggregator for anything, right?
Another question that we had, like how significant are platforms like GitHub, Lead Code, or HackerRank, for example? Like how do these impact our CV, or
Of
how?
course, very much. Let's say I interview, right?
Correct.
And from my team, you send me a resume.
Mhm.
You write 2-3 pages, and you have 3, 6, 9, 10, 11, 12 students. If I get 12 such CVs, it's very difficult to basically understand and see that okay, everything what you have written is correct information. Rather, what I will ask is from your GitHub, explain one of the code, right? If you maintain your GitHub, then whatever you are writing in your resume that you know PHP, you know Java, you know full stack, you have a proof for that, right? So maintaining your resume is important, maintaining your GitHub is important. Anything equivalent to GitHub, it's very important.
How about solving DSA problems? So I have seen in many YouTube people saying that you need to focus on DSA for your interviews, and you
DSA
need to
means
solve
data science application.
data structures and algorithm questions.
Yes, you need to solve. But again, if you think that there is a hackathon that you solve DSA questions and then get a certification, add that to your LinkedIn, that doesn't. That's probably a one condition that you are meeting, but that is not giving you the confidence that you yourself have written the code. Right? Even if you have a certification, maybe somebody else's code. Right? How do you prove that it's your code? If it is your repository, your handle, GitHub handle, you have the solution. So if you participate in hackathon, put the same code in GitHub afterwards.
Correct.
Right? Yes, you have done. You have created something. That's a proof point. Right?
Anyone else also wants to ask questions, please do, because I have a bunch of questions. It's better if you guys also interact.
Yeah, I had a question. So, I've talked to a couple of people who are working in HR, and they were like, okay, you
Working
guys,
in?
HR, those who do recruitment.
Okay.
So they've been like, okay, you are CS students, you are data science students, you will be competing with engineers, so you better like up your game. So what would you say regarding that?
Okay, so it's a very interesting question, because if you have to compete somebody from IITs who has a BTech degree
Yeah.
versus you have a BSc degree,
Yeah.
so there is a fundamental difference. The differentiating factor for you, what I think is going to be major is you can apply your things in multiple domains, right? You know economics with data science. You know how to apply data science in economics. That definitely the IIT BTech computer science will not have.
Yeah, but what about the recruitment aspects and all that?
Yes, so probably you will not apply for the same role that they are looking for, right? That's what I asked. What is the difference between a data analyst and a data scientist? What is how do you differentiate a data engineer versus a data scientist? Right? So there is an engineering problem definitely, but there is also something that is needed to apply the techniques on the domain.
Okay.
You have these chances now because you are surrounded by multi domains, right? multiple domains that you can apply. Just now what we talked about web scrolling, right? So you do it for your data science, computer science conference. You give it to anyone, they can do that for physics, chemistry conference. Only thing that they have to change that part, right? You are actually solving multiple problems at once. You understand, right?
Also, one more thing. In your opinion, would doing a double major in data science and computer science be more beneficial, or would it be better to focus on a particular subject and do something on the side?
So my experience is that doesn't matter whether you are a single major or double major. When I interview you for a position in my group, doesn't matter to me.
Okay.
What matters to me is how much independently you can think,
Okay.
how deep you can go in mathematics.
Also, I just want to give one opinion of mine. There's a lot of overlap between data science and computer
Yeah.
science. You'll be doing a lot of double work. Rather than that, if you could learn something new, I think that's better, but depends on you.
Yeah. So at some point there will be many cross-listed codes in both the departments, but my suggestion is focus on fundamentals, focus on the mathematics part, right? So if you know the mathematics part well, and if you can write, let's say, whatever you are writing in Python now, developing in Python, do you really understand the function that you are using? Right? What random forest does, how gradient descent works. Those are ready-made functions available, right? But if you try to develop a C++ program for gradient descent, then you are bound to understand how the math works. That is what we need in our industry. At least in my group, if you want to get a job, we interview everyone, like just like in our class that we don't have a traditional exam, right? We have open book exams, we have projects. Just like same thing in our group, right? We start with whiteboard, right? So we'll ask you that, okay, solve this problem. We really want to see how deep you can go. It's not about proving you that, okay, to identify that this is your limit. But we really want to understand how independently you can think. If I ask you a problem, just like that's why I told you the scaling problem, right? This question I ask in interview, trust me. The scaling thing that I give you this much of money, I want to see that how much that person can think, right? These are the skills which is essential. You can learn any programming language anytime. That's not a big challenge. Because if I can teach computer science without having any computer science course in my life, what I have learned is all on the job, right? That is easy. Syntaxes are easy. What is important is the concepts, the maths behind it. That's important. And my suggestion is don't bother about a single major or double major at this moment. Whatever you are learning, learn to the core, very deeply, very profound. That is extremely important.
Building on this question, you started off as a physicist, then moved on to computer science like roles, and then like from there you're getting into academia, and you went into academia. So you got all three kind of transitions. So what do you think you learned from each transition, or do you think it's necessary to know one? Or
Understand. So
yeah.
for me, the honest answer is this transition were not planned. Nobody can plan their career. You can aspire to have a career, right? When I was at your stage, I never thought that someday I will be talking to you, right? So I came from an academic family. My father was a professor, so I had a dream that okay, I want to teach someday, right? But what I really wanted that after my school, that I wanted to study physics. I had a conversation with my dad that if I am not studying physics, I am not studying. I will not study anymore. So that was the conversation. So I wanted to study, and then just like that, she asked that what should you explore? Single major or double major, right? And you told that there is a overlap between all these things. You gradually discover that what you like. I started as an astrophysicist, solving and studying this. But eventually, while doing all these things, I was more interested to understand how computer behaves. I was very curious. So curiosity is very important thing. But what really helped me in this journey is, so now I can talk the language that when I am going and talking to a physicist, I talk in their language. When I am going and talking to a computer scientist, I talk in their language. That's probably I can do because somehow I went through this journey. Right? You'll be able to do that, right? So if you are, when you are done with your data science and computer science, you'll be able to easily switch between these two. It's easy, not difficult. And simultaneously, if you talk to work in some of the projects in different domains, you will learn the domain as well, right? You never know. I have seen many computer science student, eventually they wanted to go for PhD in physics. Because physics also demands computers, right? If you go and search so any US national labs, right? Is it still on?
Yes.
Yeah.
Is it working?
You need to switch it on. The remote is there. Ah, we can do that also.
Shyam?
Yeah, switching. Yeah.
Yes. So I am showing a web page, something called Oak Ridge National Laboratory. Oak Ridge is a place in US, Tennessee, and this is the US National Laboratories where they are based on computing. Many other things. If you go and click what we do, you'll see. So Oak Ridge National Laboratory delivers scientific discoveries and technical breakthroughs needed to realize solution in energy and national security and provide economic benefit of the nation. This is what they do. And how they do is, they have many different areas. You see, one of the areas is supercomputing. Right? And if you see the divisions in Oak Ridge, you will see in the same team you have people from physics, people from chemistry, people from data science, everybody is coming together. Computational science and engineering. If you see, these are the things, right? So if you see, just go and search the web page, Oak Ridge National Laboratory. They work on this weather modeling. Weather modeling need to have experts who understand weather. They need to have people who understand data. It's a computer modeling at the end of the day. They need to have people who understand computer, how it behaves. Just see that and then we will see. I'm just trying to see their stuff. Not this part. This is the organization. Let's see. See the computing and computational science org chart, if it shows, there are links. I want you to just go and browse it. There is a chart that used to be there earlier. You see, they work on artificial intelligence, they work on data science, they work on software development, everything together, right? You cannot actually differentiate that this is data science, this is AI. So the target is that someday I want one of you to work there. Right? So now you work backwards. If you know that this is the goal that you want to achieve,